Okay, so let's get some more practice here with completing the square. And we'll also do a little bit of graphing after we do complete the square here. So the directions read, we're going to graph this function, but before we do that, we're going to go from standard form, this is standard form, to vertex form. Okay? Because when we're in vertex form, not too hard to graph it. After we graph it, we're going to talk about maximums or minimums of the function and look at the zeros as well. But first, let's do the completing of the square. Now remember, in order to complete the square, I want a perfect square trinomial. In order to get that, I'm going to take what I started with, x squared minus 8x. I'm going to move the plus 12 out a little bit and create some space to introduce two new numbers. Now I'm going to add one of them and subtract the other, knowing that I have to do that in order to maintain equality within my equation. Okay? I have to add one of them and subtract one of them because that's the same thing basically as adding 0. If I add 9 and subtract 9, well, it's like adding 0. So to determine what that number is, I'm looking at negative 8. I'm going to take negative 8. I'm going to square it. I'm sorry. Let me go back. I'm not going to square it first. I'm going to cut it in half, and then I'm going to square it. Okay? So, and actually I can really look at it just as 8 because I'm adding it and I'm subtracting it. So, as long as I add 1 and subtract 1, it doesn't really matter what I square. Okay? So I have 8. I'm going to cut it in half. That gives me 4. And then square it. That gives me 16. So 16 is the number I'm both adding and subtracting. The reason that I add that number is because this I know now to be a perfect square trinomial. In order to factor that, I'm not really sure why they have like another, I don't know, it seems like we have the same step here, but I'll just repeat this down. I guess the first one was setting up for it, and then the second step was actually doing it. But in any case, our equation is still balanced because we added 16 and we subtracted 16. Now the factoring part of this is to take this and factor it into a different, you're taking a perfect square trinomial and you're factoring it into a double bubble situation. Now the hint to this is whatever this number was here, when you cut it in half, so we took negative 8 and we cut it in half to get negative 4, that's the number that we put in here. It's just like saying, okay, if I were to factor this, it would be x minus 4, x minus 4. Because when I multiply that out, that gives me x squared minus 8x plus 16. So we kind of just skip over we kind of skip over the factoring piece there because we kind of already have the shortcut in place. All right, but this is x minus 4 times x minus 4, and we write that as x minus 4 squared. So that's the completing the square part. On the outside here, we just combine these like terms. Positive 12 minus 16 is a negative 4. And now you can see we are in vertex form. We have converted from standard to vertex. So we got to sketch a graph. The vertex here, now think about vertex form. When we're in vertex form, the numbers that really concern us are the h and the k. Remember that the h, we sort of use the opposite of what's in there. So the h, I'm going to use positive 4. The k is going to be negative 4. So over here on my grid, since I want to use 4, negative 4, that's to the right 4, and then down 4. So maybe I'll draw my grid somewhere up in here. Okay, since I know that I need to go to the right 4, 1, 2, 3, 4, and then down 4. That's going to put me right there. Okay, that's the 0.44. We know this thing is going to be, it's going to open up because, excuse me, because the lead coefficient is a positive 1. So we know it's going to open up. As far as finding 2 points to the left of the vertex and the right of the vertex, well, you can most certainly throw this thing in your calculator to do that, okay, and look at the table. Or you can take these points and individually substitute them back in here and see what comes out. I guess if I put in 2, 2 minus 4 is negative 2 squared is 4. 4 minus 4 is 0. So I guess I can figure out 2, 0. And if I plug in 3, 3 minus 4 is negative 1. Negative 1 squared is 1. 1 minus 4 is a negative 3. So that wasn't too bad to do just in my head. So to the right 3 and down 3. Now we know that because my vertex is where it is, we have an axis of symmetry that goes through that vertex. If I could actually hit it properly. Okay? And those points are just going to reflect. So since 3 is 1 unit to the left of 4, 5 is 1 unit to the right of 4, so this is going to be 5, negative 3, and then we're going to have 6, 0. I can figure those without even plugging those back in. So there's my parabola. Now think about what the original question asked. The original question said to give the maximum or minimum and identify its zeros. Well, the minimum we know is 4, negative 4. That's my vertex. The zeros are going to be where this thing crosses the x-axis. Okay? So the zeros of the function. Now, you know, a bit of a technicality here, but if you're asked for the x-intercepts, well, the x-intercepts, the x-intercepts would be the points 2, 0, and 3, negative 3. Okay? But the zeros are the actual, you know, x values that are going to solve this function and make it true. All right? Those are going to be the actual x values that when you plug those in, your output is 0. So that would be x equals 2 and x equals 3. Hold on a minute. That's not right. Almost made a very silly mistake there. My zeros are going to be 2, 0, and 6, 0. Or my x-intercepts are going to be 2, 0, and 6, 0. The actual zeros are going to be x equals 2 and x equals 6.